Mars, the red planet. We humans have always been fascinated by the fourth planet from the Sun, even during the thousands of years over which we could only speculate as to what Mars was. With the invention of telescopes to aid our curiosity, we began to get a clearer picture of this alien world. From what telescopes allowed us to see, we imagined a Mars that never was. Cities, canals, civilizations. A whole living peopled world appeared like a mirage at the other end of our instruments. However, we couldn't be sure. We needed more information, and telescopes could only tell us so much. There was only one way we could solve this problem. We were going to have to send in the machines.
Machines versus Mars.
However, what machine on Earth could possibly reach Mars? And who on Earth could create that machine? Humans have been toying with the idea of reaching space for many years. But it wasn't until the 20th century that technology started to open the door to the final frontier. And it was Nazi Germany who had been developing that technology. The Nazis created the V-2 rocket, the world's first long-range ballistic missile, a weapon of the Second World War. V-2 rockets began flirting with the boundary between Earth and space from as soon as the first successful tests in the 1940s. Humans saw that they could, for the first time ever, place actual human creations, machines, in space. After the war, the United States and the Soviet Union, continuing with the V-2 design and teams of borrowed German scientists, each began to explore that space boundary for themselves, both in terms of military applications and in terms of pure science. The direct exploration of Mars began with the Soviet Union. The Union of Soviet Socialist Republics was eager to demonstrate to the world its prowess in space. It had already been rather successful in space since as early as 1957 with the launch of Sputnik 1, the first artificial satellite. The Soviets were also responsible for the first man and then the first woman in space, as well as putting the first animal in orbit, the first spacewalk, and so on. Mars was a natural target for the Soviet scientific imagination. However, placing something in low Earth orbit and sending a space probe hurtling tens of millions of miles through the solar system to reach an alien planet, well, those are two entirely different things. Just how did the Soviets think they could accomplish such a feat?
Round one.
Their answer was the Soviet Mars program, a systematic, incremental, multi-year attempt to reach the red planet. And it began with the Mars 1M spacecraft, nicknamed Marsnik-1 in the West, a machine designed to accomplish what is called a flyby. A flyby is an easy way to get access to a planetary body without dealing with the expensive task of entering orbit or actually landing on the planet itself. However, as the name suggests, the visit would be a short one, like that of a tourist. For the Soviets, and indeed anyone starting out for the Red Planet, a flyby was the best first step. The Mars 1M launched in October of 1960. Unfortunately, it was a failure. The mission did not make it to Mars. It did, however, make it to Siberia in pieces.
Continue?
But did the Soviets give up?
Niet.
They followed up only a few days later with a second Mars 1M spacecraft, Marsnik 2, if you will. It failed, never to reach low Earth orbit. Soviets examined the issues surrounding these two failures and came back 2 years later, in late 1962, with 3 separate missions, 2 flybys, and audaciously, a lander mission. A lander is a machine that would simply sit on the Martian surface and gather data from one location, a step up from the flyby missions proposed so far. 2 of these spacecraft failed to leave the vicinity of Earth, including the lander mission. However, the Mars 1 spacecraft, one of the flyby missions, did make it, sort of. It was 66 million miles and over 4 months into its journey to Mars when the spacecraft suddenly stopped communicating with Earth. It would have passed Mars in June of 1963, as far as we know. Even though we can't talk to it, the Mars 1 should still be out there, somewhere, orbiting the Sun with the rest of us, even now. So far, we've learned more about the difficulty of leaving Earth rather than about how to get to the Red Planet. But the trajectory of this story is about to get interesting. A new player is about to enter the Mars game. In 1964, the United States of America finally got into the game of exploring Mars with a pair of twin probes called the Mariners. Mariner 3 and Mariner 4 were identical exploration machines built by NASA through the now famous Jet Propulsion Laboratory in California. These twin probes were designed to be flyby missions. Mariner 3 launched November 5, 1964. A covering designed to jettison during launch failed, and the probe's solar panels never deployed. Mariner 3 joined the Soviet Union's Mars 1 in a forever alone orbit of the Sun. Presumably, the two probes did not get along because of ideological differences. However, NASA's Mariner 4 probe, launched just a few weeks later, went on to make history, becoming the first ever machine to image another planet in our solar system. Imagine waking up to this in the morning paper. Modern humans were really beginning to live in their own real-life science fiction story. What Mariner 4 found was surprising. No canals or civilizations, or even water, were obvious. No magnetic field or radiation belts, like those of Earth, were detected. Readings indicated that the atmosphere was very thin, much thinner than was widely accepted. It appeared to be a dead world, cratered and exposed to space. More importantly, we found that there wasn't just an absence of intelligent life, but an absence of life of any kind. These discoveries changed the scientific and public perception of Mars forever, and raised questions that we didn't think we would be asking. What happened to this planet? After a significant number of micrometeoroid impacts over several months, Mariner 4's attitude control and signal strength were affected, and communications were eventually terminated. This hero machine sent a total of 635 kilobytes of data, including 21 full images. Meanwhile, in the midst of this interplanetary success, the Soviet Union launched the Zond 2 probe, a mission to test the endurance of equipment in deep space, including a new kind of low-thrust electrojet plasma ion engine. The Zond 2 was scheduled to impact the Martian surface during the testing process, delivering some commemorative medals. Ultimately, it failed. It lost communications with Earth several months before reaching Mars. The Soviet Union was 0-6 when it came to the Red Planet. One would assume that after the Mariner 4 success story, exploration of the Red Planet would get easier. After all, we now knew how to accomplish a flyby mission. However, Mars is a difficult destination to contend with, and is certainly a planet that likes to keep its secrets. Despite the coming successes, reaching Mars would still prove challenging. There will be many losses. One thing is sure, though. The Americans and the Soviets did not give up easily. During the launch window in 1969, the United States and the Soviet Union each launched missions. The US launched Mariner 6 and Mariner 7. Both were successful flyby missions and gave us more detailed insight on the Martian atmosphere. Like the famous Mariner 4 probe, Mariner 6 and 7 managed to photograph heavily cratered sections of Mars, accidentally ignoring the true landscape of the planet. As a result, we continued to have the impression that Mars was more like our own moon. Between the two probes, 201 images were sent back to Earth. Meanwhile, the Soviet Union attempted their own pair of machines, specifically a pair of orbiters. An orbiter is a kind of probe intended to stay in orbit of Mars for an extended period of time, instead of just rushing past it in a flyby. The Mars 2M orbiter missions both failed during launch. The second launch failed only 100 meters above the launch pad, spreading toxic chemicals all over the area, which resulted in a temporary shutdown of the Baikonur Cosmodrome launch complex. However, the Soviets pushed the envelope by advancing the whole Mars game to the orbiter stage. The United States launched Mariner 8 in 1971, the first American attempt at an orbiter. It failed during launch. The Soviet Union tried the Cosmos 419 probe, which made it to Earth orbit. However, because of an ignition timing error, the mission failed, and Cosmos 419 burned up in Earth's atmosphere. Next, the Americans launched Mariner 9. their second orbiter attempt. It was successful. Mariner 9 became the first machine ever to orbit an alien planet, reaching Mars on November 14, 1971. Interestingly, Mars was engulfed in a global dust storm when Mariner 9 arrived, forcing scientists to delay imaging until early 1972. However, when Mariner 9 resumed its mission, it discovered some of the red planet's most amazing landforms, and a truer portrait of Mars began to emerge. Dried riverbeds, evidence of wind and water erosion, as well as huge, extinct volcanoes such as Olympus Mons, the largest volcano in the solar system. The mission also discovered a canyon 2,500 miles long, later named Valles Marineris in honor of the Mariner 9's achievements. After 349 days in orbit and over 7,000 images covering 85% of the planet, Mariner 9 concluded its duties and retired to orbit Mars silently until 2022. Not to be outdone, the Soviet Union also saw some successes during the launch window in 1971 with the Mars 2 and Mars 3 missions, which in true Soviet style upped the ante by including not just orbiters, but landers and rovers. Until now, no one has even attempted to put a rover on the surface of Mars. Mars 2 and 3 arrived just a couple of weeks after Mariner 9, during the global dust storm of 1971. The Soviets were unable to delay their missions the way that the Americans did, in order to wait for the storm to subside. As a result, Russian imagery initially consisted of featureless dust clouds. Additionally, the lander and rover portions of the missions went ahead as automatically scheduled. The Mars 2 descent module, containing the lander and the rover, failed during Martian entry, becoming the first ever human-made object to impact the surface of Mars. The Mars 3 descent module, also containing a lander and a rover, successfully touched down on the Martian surface, and communications occurred for about 15 seconds before failure. Meanwhile, the Mars 2 and 3 orbiters continued operations for several months, providing valuable information on the content of the Martian atmosphere, including hydrogen, water vapor, and oxygen levels, as well as surface temperatures and other information leading to the creation of surface relief maps. The Soviet Union's attempts at Mars continued alongside those of the United States throughout the 1970s and 80s, resulting in a variety of machines. Computer problems prevented Mars 4 from achieving orbit. The Mars 5 orbiter mission reached Mars successfully, but a micrometeoroid impact may have damaged the craft, leading to a failure only a short time later. The Mars 6 and 7 lander missions both failed. 6 crashed on Mars, and 7 missed the planet entirely. Meanwhile, the Americans began the Viking program, a series of 2 space probes that each consisted of an orbiter and a lander. Launched in 1975, the Viking missions, the most expensive interplanetary missions of the day, were immense successes, and the information gathered by these machines laid the foundation of what we knew about Mars from the early 1980s through to the early 2000s. The Viking landers gave us our first real analysis of Martian soil, allowing us real insight into the history of Mars. The landers conducted biological experiments in order to search for life. No organic compounds were found, but the results are still being discussed today. And imagery from the Viking orbiters indicated water flowed across the surface in very large amounts, possibly even through rainfall at some point. This information was extraordinary. That image of a dead cratered desert world with the super thin atmosphere we saw back with Mariner 4 was replaced with an active, wetter, more interesting Mars. Water played far more of a role in shaping the Martian landscape than we knew. The possibility that Mars may have had life at some point grew stronger once we became aware of how much water, past or present, was actually at work on the planet. Nearly a decade after the success of the Viking program, the Soviet Union launched what would be their last hurrah to Mars, Phobos 1 and 2, a pair of probes destined for the Red Planet with an emphasis on looking at the Martian moon, Phobos. The Phobos probes were truly an international effort, featuring cooperation from 14 different nations, including the use of NASA's Deep Space Network. Phobos 1 failed when a software update unexpectedly crashed communications. Phobos 2 partially succeeded. The orbiter successfully returned 37 images of the Phobos moon and helped investigate Mars itself. The probe lost contact before its planned pair of landers could be deployed to the surface of Phobos. This was the last mission to the Red Planet undertaken by the Soviet Union, which was dissolved in 1991 and replaced with the Russian Federation. In 1992, 17 years after the successful Viking program, the United States got back into the Mars game with the Mars Observer, which failed just before reaching its target. In 1996, 21 years after the Viking program, NASA launched the Mars Global Surveyor, a successful orbiter that went on to map the entire Martian surface, monitor global weather, study the structure of the Martian atmosphere, and act as a communications relay for sister orbiter missions. The Global Surveyor was also instrumental in the discovery of apparent recent water activity on Mars, in the form of before and after photos of what looked to be water-carved gullies. Again, our perceptions of how water works on Mars continued to evolve. The Russian Federation, taking up the mantle of the previous Soviet space agency, launched the Mars 96 in the year 1996. The mission failed during launch. However, Russians continued to push the game to new heights by attempting new kinds of missions. Mars 96 was not only an orbiter and a lander, but it also contained ground penetrators too.
The Penetrator.
The penetrator portion of the mission was going to be a way to look at areas 5 or 6 meters below the surface of Mars. Also, during the 1996 window, NASA launched the Mars Pathfinder mission, part of NASA's cheaper, faster, better philosophy, promoted by NASA Administrator Daniel Goldin. The Pathfinder mission, which consisted of a lander and a rover called the Sojourner, succeeded. This was the first truly successful deployment of a rover on the Red Planet. The Pathfinder mission conducted investigations of soil and rock composition, atmospheric pressure, wind speed, and temperature. Suddenly, Japan enters the game. Japan's Nozomi spacecraft, launched in 1998, was designed to study the Martian upper atmosphere and its interactions with solar wind. However, it failed en route and never entered orbit.
Failure.
Japan did succeed in changing the game of Mars exploration by stepping up to be the third participant. Until now, Russia and the United States had been the only real players. Despite the entry of Japan and Russia's ongoing efforts, the United States continued to pursue Mars with vigor. In 1998, NASA launched the Mars Climate Orbiter, which failed, disintegrating the Martian atmosphere due ultimately to a software mix-up over measurement systems. In 1999, NASA had another failure with the Mars Polar Lander, which lost communication during the final descent phase and slammed into the surface. The Polar Lander mission also carried 2 miniature penetrator probes, both of which went down with the ship. NASA picked up another win with the 2001 Mars Odyssey Orbiter, a successful mission that looked for evidence of past or present water and ice. It also acted as a communications relay for other Mars missions. The Odyssey is still functioning in orbit of Mars right now. It holds the record for the longest surviving, continually active spacecraft in orbit around an alien planet. 14 years and counting. In 2003, yet another player entered the game in the form of the European Space Agency, launching the ambitious Mars Express orbiter and lander. The orbiter was successful and has given us new insights into the composition of Mars, discovering water ice in the polar regions and possible methane and ammonia in the atmosphere. Finding these two gases may indicate a geological or biological origin. Both of these compounds break down rapidly, pointing to relatively recent emissions. Suddenly, we had to figure out a whole new group of questions to ask. Just like the NASA Mars Odyssey mission, the ESA's Mars Express is also still functioning today. The Mars Express lander component, however, named Beagle 2, lost communication shortly after touchdown.
Failure.
Next came a whole cluster of successful missions. NASA's famous twin rovers, Spirit and Opportunity, were sent to the Red Planet in 2003. They provided incredible information about Mars, including information relating to geology and surface exploration. Studying the soil and the surrounding rocks, scientists concluded that Opportunity had landed in an area once drenched in water. Spirit lasted until 2009, over 20 times longer than planned. Opportunity is incredibly still functioning nearly 12 years after the end of its original proposed mission. Opportunity is the rover that just won't quit. The ESA's Rosetta mission, launched in 2004, successfully conducted a brief flyby of Mars on its way to the comet 67P. NASA launched the Mars Reconnaissance Orbiter in 2005 and the Phoenix Lander in 2007. Both were successful. Russia put in another entry with the Phobos Grunt mission in 2011, a lander that involved a sample return mission, meaning that the intent was to bring material from the Martian moon Phobos back to Earth. It failed. Also launched alongside Phobos Grunt was the Martian orbiter Yinghuo-1, China's first entry into the Mars game. Then, in 2011, NASA launched its most ambitious mission yet, the Mars Science Laboratory, which consisted of a large rover called Curiosity. After a crazy landing procedure, Curiosity successfully deployed on Mars and is currently investigating Gale Crater, looking for environmental circumstances that may have supported microbial life, gathering more information on how water works on Mars, and scoping out the area in terms of future human habitability. The Curiosity success story is ongoing and promises to reach new heights as the rover slowly investigates its way up the side of Mount Sharp, an 18,000-foot-high mountain inside Gale Crater. The people of Earth have no intention of slowing down when it comes to Mars exploration. Their invasion of Mars through machines is still being planned and executed. This includes NASA's MAVEN mission and India's Mars Orbiter mission, 2 orbiters in successful operation right now. Future missions include more landers, orbiters, and rovers through the year 2020 and beyond, including an updated version of the Curiosity rover and a possible entry from the United Arab Emirates. In all, many machines involving several different nations have been sent to the Red Planet. 27 of those machines were successful. 7 are still active right now, either on the surface or in orbit. With all these machines and no humans as of yet, it is safe to say that Mars is the one planet in the whole solar system dominated by machines. Thank you for watching. Please feel free to leave comments below and subscribe to the channel for future episodes.